Hi students, welcome back to today's class. Today we are going to see data structures. Under data structures, we are going to see the first data structure, that is linear lists. Okay, so you all know that what is meant by lists. Okay, list means it's a collection of items. It may be in ordered way or unordered way. So here linear in the sense it is an ordered collection of items. Okay, collection of items only going to be represented as a linear list. Okay. So here in this chapter, we are going to see the following topics, that is introduction and elementary data representation, and then different data structures, and then operations on data structures, then linear list data structures, and nested two-dimensional lists in Python. So today in today's class, we are going to see the first four topics, that is introduction, then elementary data representation, different data structures, and operations on data structures. Let me move on to the first topic, that is introduction. So why we need to study data structures and what is meant by data, and how we can represent the data, all those things we will discuss now. So the computer system is used essentially, that is importantly, as the data manipulation system. So it is going to be, computer system is going to be used as what? Data manipulation system. That is, it is working on data only, where data are very important thing for computer system. So without data, computer system is a idle one. So we need to give some kind of input to the computer in order to perform some kind of operations. So we need to feed the data. So the data can be referred to in many ways, like data items and data structures. Like that we can refer the data in a different form. The data being an active participant in the organization's operations and planning, data are aggregated and summarized in various meaningful ways to form the information. So data are going to be used in many organizations operations, and the data are going to be aggregated. Okay, it's going to be collected and summarized in a various different ways, meaningful ways to form the information. Okay, that processed data is only known as what? Information. The data must be represented, stored, organized, that is arranged, processed and managed so as to support the user environment. Okay. So in order to support the user environment, data must be represented and stored, organized and processed and managed. Okay. All these factors very much depend upon the way data are aggregated. Data structures are an effective and reliable way to achieve this. Okay, so if you want to represent the data, if you want to store the data, and if you want to arrange the data in some order, okay, and if you want to process the data, okay, if you want to work on the data, and if you want to manage the data, managing means like insertion, deletion, all those things, if you want to perform, for that the data structures is an effective tool. Okay. So first part of this chapter introduces the data structures and basic terminologies used for them, and different commonly used data structures we will see in the first part of this chapter. And the second part of the chapter talks about list data structures. So only we are going to see the linear list data structures, and you have learnt about the list data type in your previous class, but here we will see them in a data structure over there. That means in a detailed way we will see the linear list data structure. Okay, so already you have learned lists data types under basic data types category. Under Python we have seen lists. Okay, so here we are going to see linear list implementation. That is the data structure concept, how the lists are going to be implemented in Python, that we will see in a detailed way. Next topic is elementary data representation. So elementary representation of data can be in the forms of raw data, data item and data structures. What is meant by raw data? Raw data are raw facts. Okay, these are simply values or set of values. For example, a person's date of birth, if you are asking, so he will say the date of birth. So the date of birth answer is actually raw fact. Okay, so the raw data or raw fact, these are simply a value or a set of value, group of values. Okay, so data item represents single unit of values of certain type. For example, I have given one example, column name. If you consider a data that is table, okay, so we have studied in MySQL tables, no? So in the tables, we are going to assign the column names. Okay, that is a student serial number and student name, student date of birth and address. So every column name here is going to represent the data item. Okay, So data item represents single unit of values. For example, if you consider date of birth, so date of birth is belongs to which data type? It is belongs to date data type. So we have studied different data types in MySQL, no? That is in database concepts. So database concepts are going to be implemented with the help of this the data structures only. Okay, so data are going to be organized, and if you want to search any particular data from the database, this data structures concepts we need to use for extracting the data from the database. So for that, this data item, that name is going to be used in the data structure concepts because it is representing single unit of values of certain type. Example, date of birth or student name. Okay, student name is belongs to string, that is character data type, variable character or char data type. CHAR we will use, no, char or char data type. So it is a unit of values. So under student name, you are going to assign only character values. So single unit of values of same type or certain type. That is only known as data item. Next, data structures means what? A data structure is a named group of data of different data types. Okay, it is given a name. For the data structures, we are going to give a name. It is a named name means what? Variable name, the function name, all those things we are saying, no. Identifier only is called a name. Okay. So data structure is a named group of data of different data types, which is stored in a specific way. So we will store in a particular way. So for every data structures, the data element storage will be varying. Okay, so the way in which we are storing the data, that will be varied from one data structure to other data structures, that we will see in the next topic. Okay, so and can be processed as a single unit. So data structure means it is a named group of data of different data types which is stored in a specific way, and it can be processed as a single unit. That is, a data structure has a well-defined operations like insertion. We are going to see the different type of operations which we are going to perform on the data structure. It has well-defined operations, and it has a behavior, and it has some properties. Data structure has some properties. Okay, so data items are used as per their associated data types. So according to the data types, the data items are going to be used. While designing a data structures, one must determine the logical picture of the data in a particular program. Choose the representation of the data and develop the operations that will be applied on. So we need to choose which way we need to represent the data, either in the form of linear list or in the form of stack or in the form of queue. So that representation we need to choose, and we need to develop the operations like insertion, deletion, traversal, and then updation, all those things. Okay, so we need to develop the operations that will be applied on the data. Okay, so according to the data type only we can perform the operations. So next one is data type versus data structure. What is meant by data type? A data type defines a set of values along with well-defined operations stating its input and output behavior. Okay, so which type of input the data type need to take and which type of output it will produce. Okay, so it is defining a set of values along with well-defined operations. Okay, you cannot put decimal point in an integer. For example, operations in the sense, we cannot put the decimal point, that is dot, we cannot put in an integer value, or two strings cannot be multiplied. We cannot multiply the two strings, that we have discussed in the under the database concepts itself. That is in Python data types when we discussed, no, that time itself we have discussed we cannot multiply two strings, and we cannot add a string with a number. Okay, so like that some operations cannot be performed. That and all we need to understand before we use the data type and before we apply the operations on the data items. So on the other hand, a data structure is a physical implementation that clearly defines a way of storing, accessing, manipulating data stored in a data structure. So it will clearly defines in which way we can store the data, okay, and which way we can access the data. That means we can retrieve or we can write the data into the data structure, okay. And manipulating data, manipulation in the sense deletion, updations only is known as manipulation, okay. So in which way data can be stored, accessed, and manipulated in a data structure, okay. So the data stored in a data structure has a specific work pattern. So it is going to be stored in one particular pattern. Example, in a stack, all the insertions and deletions are taken place at the one end only. So that is at the one end only insertion and deletion can be taken place. That we will see in a picture in the next topic. For example, Python supports lists as a collection of collection data type which can store heterogeneous data types of elements. That means heterogeneous means what? Homogeneous in the sense similar data elements. Okay, heterogeneous in the sense the list can hold integers also, then floating point values also, and then string values also it can hold. Okay, so the Python supports list as a collection of collection data type which can store different data types. Okay, heterogeneous in the sense different types of elements can be stored. Okay, it will not be similar elements. Heterogeneous in the sense different elements, different types of data are going to be stored or supported in the list. Okay, but when we implement list as a data structure, but in a Python we have studied list can store different types of data elements, but when we are implementing list as a data structure, its behavior is clearly pre-decided. Example, it will store all the elements of the same type only in case of the list data structure. For searching and list elements will be pre-sorted and so forth. That means when you are searching elements, all the list elements are going to be sorted. If you are going to perform the binary search, elements need to be sorted in the data structure. Okay, so list here is going to be used as a data structure. It is not Python list. So when we are implementing list as a data structure, that is when it is going to handle different number of elements, no, many number of elements. Okay, data elements. Uh, it will store the elements of the same type only, similar type only. Okay, it will not store heterogeneous types. Next one, different data structures. Data structures are very important in a computer system as these not only allow the user to combine various data types in a group, but also allow processing of group as a single unit. Okay, so it not only allows the user to combine different data types in a group, it is allowing the processing of group as a single unit. Okay, as a single unit, we can process all the elements in the data structure, thereby making things much simpler and easier. So as a single unit, every element are going to be stored in a one data structure so that we can access all the elements in an easier way and in a simpler way. Accessing in the sense what? Reading the elements and writing, updating the elements in the data structure only known as what? As a group or single unit. Okay, so we can read and we can read and we can write from the data structure, that is only known as accessing. Data structures can be classified into following two types. That is, first one is simple data structures. These data structures are normally built from the primitive data types like integer. Primitive means what? It's a basic data type. Okay, primary data types. So these data structures are normally built from primitive data types like integers, reals, and characters. Reals in the sense a floating point only is called as reals here, and characters Boolean. Following data structures can be termed as simple data structures. Arrays and linear list. Arrays or linear list are known as simple data structure. Okay, next one is compound data structures. Uh, Simple data structures can be combined in various ways to form more complex structures called compound data structures. So simple data structures, no, if it is going to be combined in different ways in order to form the more complex structures, then it is called as compound data structures. So that is simple data structures only going to be formed in a different way. Compound data structures are classified into the following two types, that is linear and non-linear data structures. Okay, so if we are going to combine the simple data structures into a linear way, okay, then it is known as linear data structures. Linear means in an ordered way. Okay, so these data structures are single level data structures. Linear data structures are single level data structures. Data structure is said to be linear if its elements form a sequence. So that this one you need to understand. If the elements are going to be form a sequence means what? One after other, if the elements are going to be stored, okay, one after other in a continuous way, if it is going to be stored, then it is said to be a linear data structure. Following are the examples of linear data structures. First one is stack, second one is queue, third one is linked list. Okay, these are the three simple linear data structures. Next one is non-linear data structures. These are multi-level data structures. That means example for multi-level or non-linear data structures non-linear data structure is tree. That means elements are not going to be arranged in a sequence. So in any place, wherever the memory is available, it is going to be placed. So like that, non-linear data structures are going to be arranged or stored in a memory. Okay. So Python's, you need to note down here one thing. Python's built-in linear data structures are, okay, built-in already defined linear data structures are, okay, lists, tuples, dictionaries and sets. These are the four built-in linear data structures which are available in the Python. Python offers many linear built-in data structures other than lists. That is tuples, sets and dictionaries. Other than this linear lists, we have tuples also, dictionaries also, sets also. Okay. Next one is data structures and its types, diagrammatic representation. So data structures, we can categorize it into simpler data structure, that is simple data structures. Under this simple data structures, we are going to have array or linear list. Okay, we can call it as array or a linear list also we can call. Next one, compound data structures. That is when you are going to make a simpler data structures in a different ways. When you are going to combine simpler data structures in a various ways, then we can form the compound data structures, that is complex structures. Okay, in that first category is under compound data structures, we have first category as linear and second category as non-linear. So under linear, we have three types, that is stack, queue and linked list. Okay. And then under non-linear, we have an example, that is tree. Okay. We are going to see how these stack and queue, linked list and all performing its operations, or how it is going to organize the data. Okay. So linear lists, first we will see linear list arrays. Okay. So linear lists or arrays refer to a named list of finite number of similar data elements. So the same data elements are going to be stored under one name. See, for example, LIL, that is the linear list. Okay, linear list only, it is represented as LIL. This is one name. Okay, so in this name, LIL of n, if you are mentioning square bracket inside n, so it can able to store this LIL, that is linear list identifier. It can able to store n number of elements of same type. Okay, integer means integer types. Floating point, if n is mentioned as integer, so it can assign, that is LIL of 0. If you are assigning for LIL of 0 as 10, so 10 is an integer. Okay, then LIL of 1 will be assigned with 20. So 20 is also integer. So similar elements only, similar data elements only going to be stored in this linear list or array. So this is an example for linear list or an array. Okay. LIL of 0, it is going to store only one data element. Then next data elements will be stored in 1, that is one index, and second in a second index value, LIL of 2, another element is going to be stored. So every element, whatever element we are assigning this to this linear list or arrays, that is going to be similar data type only. Okay. So each of the data elements can be referenced respectively by a set of consecutive numbers. See, like this 0, 1, 2, 3, like that. Consecutive numbers, that is continuous numbers only, are going to be used for a reference. Okay. So data elements, each data elements can be referenced respectively by a set of consecutive numbers, usually 0, 1, 2, 3, n, like that. If you are going to have n number of elements, up to n it will go. Okay. So if the name of the linear list of 10 elements is LIL, okay. For example, name of a linear list of 10 elements is LIL. That means LIL is the name of a linear list. It is going to have 10 elements, that is from 0 to 9. So 0 to 9, if you count how many elements it will come. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 10 elements. Okay. So 10 elements it will come. So that is the name of the linear list here is LIL. Then its elements will be referenced as shown. Okay, that means whatever elements I have said, LIL of 0 is equal to 10, LIL of 1 is equal to 20, and then 2 is equal to 30, and then lil of 3 is equal to 40. Like that we can assign n number of elements to this every index value. Okay, so arrays can be one dimensional. So here it is, this example is one dimensional only because only one value, one index value only used here, so it is called as one dimensional. Arrays can be one dimensional, two dimensional. Two dimensional means 0 comma 0, like a matrix format. Okay, and then multi-dimensional. So two or more dimensional means it comes in the form of tabular format. Okay, so we can represent the values in the tabular manner. That means you know how the matrix values, matrix elements will be written in the max. So like that we can arrange the elements in a matrix format when you are going to use the array in the form of two-dimensional way. Okay, two or more dimensional way. If you go means we can write the elements, or we can represent the data elements in the matrix format. Next, in Python, arrays are implemented through list data types as linear list only, or through NumPy arrays. So how we can implement the arrays in Python? So arrays are going to be implemented through list data types. Array is also one of the data type only. Okay, array is one of the data type, and it is implemented through list data type as linear list, or through NumPy arrays we can implement the arrays concepts in Python. Okay, next one data structure, that is linear data structure, what we are going to see is stack. So stack data structures refer to the list stored and accessed in a special way, where LIFO, how we can access the elements. Okay, it is also referring to the list only. The stack data structures are also referring to lists there, and it is stored and accessed in a special way, that is LIFO, that is last in first out technique. LIFO full form is last in first out technique is going to be followed in order to store the list of elements and also to access the list of elements. See, if you see the stack of plates, when you are arranging the plates in this order, so in one after other, if you are arranging from bottom to top, see here from bottom to top, if you are arranging the plates one after other, so we cannot take that bottom plate immediately, yes or no. So if you want to take the bottom plate, you need to slowly uh, keep the top plates in the bottom. Okay, so you need to remove that bottom top plates first in order to access the bottom plate. Okay, so in that manner only you can access the data elements which are going to be stored in the stack also. That is, if you want to access the bottom part of the element, you need to first remove the top elements. Okay, so from the top, one by one you need to remove all the elements one by one, then only you can able to reach the bottom element. So in that order, in that way you can access the elements, that is you can read the elements from the stack. Okay, if you want to insert the elements also, see, if you want to keep the plate also, the new plate is going to be placed at the top only, not at the bottom or at the middle. Okay, so you can place at the top of the plate only, you can place the new plate. Okay, so in the same way, new element is going to be inserted at the top only. Okay, so in stacks, insertions and deletions, like insertion means what? Inserting an element, and deleting an element, removal of element. Okay, takes place only at the one end. See, that is at the top only. Top only it is going to be done. Okay, so call the top. So that means in stack, insertions and deletions takes place only at one end, called the top. Stack is similar to stack of plates as shown in the figure 9.2a. Note that plates are inserted or removed only from the top of the stack. See here, plates are going to be inserted and removed only from the top of the stack only. So what is the principle of a stack? Stack will be performing its operations in the principle of last in first out technique. That is, lastly inserted element only going to be removed first. So in that manner only the stack operations will be performed. The elements of stacks are going to be accessed in the last in first out method. Next, what we are going to see is queues. Queue data structures are first in first out list. Okay, so queue data structures are always called as first in first out list. So in normally when we are standing in a queue in a theater or in any place, if you consider, okay, for voting also. Okay, for if you go and put voting, no, in that case also queue only we will form. Okay, So the person who is standing first will be removed first, okay, will be deleted first, and the person who is standing last will be removed the last. So the queue concept of data structure, that is queues data structures, will follow first in first out principle, okay, where insertions takes place at the rear end, that is at the back end. Insertions are taken place in the queues, and the deletion taken place at the front end. So that removal can be done at the front end, and the pupil will be joining at the back end. Okay, so front pupil will leave and back pupil will be attached. Okay, that like that the principle, that is queue data structures will be working. Queue is much the same as a line of people. See here, line of people waiting for their turn to vote. Okay, so first person will be the first to vote, and the new person can join the queue at the rear end of it. So at the back end of it only, the last persons can be joined or attached here in the queue. Next data structure is linked list. So linked list are a special type of list of some data elements linked to one another. So some elements are going to be linked with another element. The logical ordering is represented by having each element pointing to the next element. The logical ordering is represented by having each element pointing to the next element. Each element is going to be called as node, which has two parts. That is info part, and the other one is reference pointer part. Okay, so the info part which stores the information, and the reference pointer part which points to the other element, next element, that is it stores the reference of the next element. Okay, so this linked list have multiple nodes. So every node is going to represent one information and one reference part it will be having. Okay, so every node will have two parts, one is info part and another one is called reference pointer part. Okay, so reference pointer means it is having address of the next element. Reference means what? Address. Okay, so it is going to refer with the help of the address. No, the next element is going to be referred in this next element address is going to be stored in this reference pointer part. Okay, it stores the reference of the next element. So figure 9.3 shows both type of lists, that is singly linked list. This is known as singly linked list and doubly linked list also. Doubly in the sense it will be having, each node will be having two reference pointer part. Okay, that is only called as doubly linked list. Double side we have reference point. One is for indicating the next element, one reference point for indicating pointing the next element's address, and the previous one is for pointing to the previous element. Okay, so in singly linked list, nodes have one reference pointer, that is next only it will be there pointing to the next node, whereas nodes of doubly linked list. So if it is a doubly linked list, every node, okay, nodes of doubly linked list have two reference point. One is previous and another one is next. Okay, so previous will be pointing to the previous element and next will be pointing to the next element. So here itself in the diagram you can see the difference. In a singly linked list, we have starting point. So first node as called as starting node, and from that node, next is indicated. That is a reference pointer part is attached with the first node. That is holding the address of the next element. So with that, the next element is connected. So same way, next node is having the address of another one. So like that, every node will be having the address of the next one. Okay, so at the end it will not be having any address. At the end, no, end of the node, no, end node will not be having any address. So with that we can understand that that is the last node. So same way in a doubly linked list you can see the diagram. So the first node will be having only one pointer that is indicating the first node, and first node, from the first node we have two pointers, two arrows. Okay, so one arrow to point to the next node, another arrow from second node to first node. Okay, so that is second node will be having the reference pointer of the first node. Okay, so the address of the first node will be there at the second node's previous part. Okay, in the same way, all the other nodes are also having the next reference pointer part and previous reference pointer part will be there for every node in the doubly linked list. Okay. Now, non-linear data structures we are going to see. Till now, we have seen the different types of linear data structures. Under compound data structures, no, linear list arrays, that is simple data structures, linear list arrays we have seen, and then stack queues, linked list under compound data structures we have seen. Next, we are going to see non-linear data structures and compound data structures. Okay, so this is the way we can represent the tree. So every circle is indicating the node here, and the lines is indicating the connecting point. Okay, lines are used to indicate the connections. So trees are multi-level data structures, okay, having a hierarchical relationship among its elements called nodes. So every element of this multi-level data structures, no, that is tree data structure, no, will be having relationship among its other elements, among its elements. Okay, it is called as, that elements are called as nodes. The topmost node is called the root node. This A is called the root node, root of the tree. And the bottommost nodes, that is H, I, J, K, L, these are nodes. These nodes are called as bottommost nodes, are called as leaves of the tree. So this is considered to be a tree data structure. In that, the top node is called as root of the node, root of the tree, and the bottommost nodes are called as leaves of the tree. Each of the nodes has some reference pointers pointing to the storing the reference of the other nodes below it. So that is, A will be having the address of B and P and C, like that. Every node, if it is connected with the other node, that node's address will be there in the previous node. So like that, there will be some reference pointers in order to point to the nodes which are placed below that nodes. Next, we will see the operations on data structures. With this, we will end up this video. Okay. So what are the operations we can perform on data structures? So data structure in the sense what? We can arrange the data in one particular format. Okay. All the data are going to be arranged in one particular order. Okay. In queue, we will arrange the elements. We will store the elements in first in, last in, first out. That is, in a stack, we will store in last in, first out principle. And FIFO principle or LILO principle is applied for queue. Like that, every data structures will be holding its elements and will be connecting other elements address in a different format. Okay, in a different data structures, in a different way we can arrange the elements or organize the elements. So after arranging the elements or after storing the elements, what and all operations we can perform on the data structures? After we store the elements in the data structure, how we can, what operations and all we can perform on the data structures? Let us see now. The basic operations that are performed on data structures are as follows. That is, first one is insertion. Insertion means addition of new data element in the data structure. That is, adding new data element in the data structure. And totally six operations we can perform. First one insertion, second deletion, third one searching, traversal, and fifth one is sorting, and sixth one is merging. Okay, so next, deletion. Deletion means removal of data element from a data structure. The data element is searched for before its removal. So before we remove the data, we need to search for the data. So for that, we will go for searching. Searching involves searching for the specified data element in a data structure. Okay. So if you want to delete any element, you need to compulsorily do the searching operation. Then only after searching the element only, you can do the deletion. Okay. So traversal means visiting every node, every element at once. Okay, so traversal of data structure means processing all the data elements of it one by one. So one by one, whatever elements are available in the data structure, that is going to be visited or processed at least one. Okay, one time. Then sorting. Sorting means what? Arranging the data elements of data structure in a specified order is called sorting. So either in ascending order or in a descending order, we can arrange the elements. That arrangement of data elements in a data structure is only known as sorting. And then merging. Merging means combining. Okay, combining elements of two similar data structures to form a new data structure of same same type is called merging. For example, if you have list of 10 students names and a list of another 10 students names, if you are going to combine these two, that is section A, section B, if you are having two sections and you are going to make that section A and section B as one section, means you need to combine the list of names. Okay, so in that case, merging will be useful. So merging means same number of elements, that is names of students only I am going to merge. So same type of elements are going to be grouped, that is from one list to another list. List 1 and list 2, both the lists are going to be combined together in this concept merging. Okay, in the operation merging, we are going to combine the elements of two similar data structures to form a new structure of the same type. Okay, it is called the merging. In the next video, we will see linear lists and some of the operations how we can perform in the linear list, that and all we will discuss in the next video. So with this we will end up this session.